One of the problems that comes up frequently is partitioning a line segment into some particular fractional ratio. And that's what we hope to attack today. This actually comes from the Idaho State Standards and is a question that we see frequently, though it's not always included in the curriculum or the textbooks. Let me give you an example. Let's say I've got a couple of points here that I'm going to graph on a coordinate system. Okay, let's say I've got this going on here. And let's superimpose a coordinate system on it. Okay, so here's the way the question kind of reads. All right, you're given 2 points, and you're asked to find a point in between the 2 points that divides the segment, the resulting segment, into a particular ratio. In this case, I'll call this point A, and point A is 2, 4, 6, -6, -1. And point B here is 2 and 3, okay? And so you'll see something like this. Find C, find C so that AC is, let's do 3/4 of AB. Okay, and that's what we mean by a ratio. So AC is going to be 3/4 of the ratio, 3/4 of AB. Not quite as long as AB, but 3/4. Okay. Now the curriculum material in our course gives you a formula to use, and it's rather complicated. The situation is not as complicated as it seems. If you're comfortable with the formula, by all means use the formula. But I'm going to give you an alternative way to solve the problem, okay? And here's what I'm going to do. I'm going to draw a triangle, a right triangle between A and C, A and B, okay? And we're going to talk about what that ratio means, okay? This involves some understanding of what fractions mean. So the first thing I want to talk about is in a fraction, the numerator, the top number of the fraction, tells you how many pieces we're talking about. And the denominator of the fraction tells you what kind they are. Okay, so the 3 3/4 tells me how many there are. There are 3. And the 4 tells me what kind. They are quarters, okay? They are fourths. So we take the whole and we divide it into 4 equal parts, and then we take 3 of those, okay? So if I look at it this way here, I can see in my right triangle that the width from A to B, and I can count if you want, right, is 2, 4, 6, 8. I can also get that 8 by subtracting the x coordinates. 2 minus -6, okay? And that's where you get that in the formula. 2 minus -6 is 8, because minus a negative is plus. But you can get that just by counting. Graph and count. How wide is the right triangle? Okay, and the key here is that it is 8 units wide. Okay, I'm going to do the same thing with the vertical component. Okay, I can count and see that it's 4 units tall, or I can subtract to find the change in y. So I can subtract 3 minus -1. And 3 minus -1, 3 minus -1 is 3 plus 1, or 4. Okay? So now let's treat this 3/4. I know I need to divide these into quarters, okay? And so I'm going to do that here. into quarters. 8 divided into quarters, 8 divided by 4 is 2. So if I were to divide the bottom of this right triangle into 4 equal pieces, they would be into units of 2. So as I count off by 2's, there's 1 quarter, 2 quarter, 3 quarters, 4 quarters. 1 quarter, 2 quarters, or a half, 3 quarters, and 4 quarters, or a whole. Notice the 3 quarters occurs right here. Okay, and I can actually answer the question about what point C satisfies the requirement that AC be 3 quarters of AB right now. But I'm going to go a little bit further. But I can answer it this way. It's that point right there, 2, 0. Okay. Let's go ahead now and look at it in terms of y. If I take 4 and divide by 3, 4 divided by 3, 4 divided by 2, or 4 divided by 4. 4 divided by 4. I don't know why I have that here. 4 divided by 4 is 1. So if I want to divide this distance of 4 into quarters, I'm going to go count off by 1's. 1, 2, 3, 4. So this represents 1 quarter, 2 quarters, 3 quarters, and 4 quarters of the whole thing. And so if I go with the 3 quarters, which is the fraction we were after, and go straight over, you'll notice it arrives at point C again. So there's point C. So I can clearly see that C is 2, 0. I hope that makes sense. If you're having trouble with the formula, try graphing the situation. Draw the right triangle. Divide the width by the denominator of the ratio or the fraction, and then count off the numerator of that. And then do the same for the vertical. Divide the height of the triangle by the numerator of the fraction, and then count off the number of the numerator. And find the intersection of the 2 points for point C.